I think that these three values are the only possible solution that is consistent with the observed measurements for Planck's constant, for vacuum light speed, for elementary charge, E, and so forth. And that there is no other set of values which can simultaneously satisfy all of these equations. One interesting thing that people are talking about is that actually bit velocity, the velocity that the quanta move, is actually pi times c. That's faster than light. So that all of this talk about, is there anything faster than light? Well, yes, there is. Or if there's not, you are challenging what this slide is saying. And if you can challenge it and show that there's anything wrong in this slide, please step forward. I invite you, find something wrong with this. If there's something wrong, I would love to know.
Well, how is pi involved exactly?
Well, this gets to the whole idea. If you look at the Speetle model, there's no such thing as light transmitting in a straight line. As a matter of fact, particles don't move in a straight line either. They couldn't, could they? There are 6 faces to the spot cube, and the only way for a particle to move, they only can move through one of those 6 faces. They can't move in any arbitrary direction at that level, microscopic level of analysis, which means on the whole, actually light doesn't go in a straight line, nor do particles. Things go in many paths to arrive at the final destination. That's one good thing about Feynman. One of Feynman's ideas in quantum electrodynamics was that you had to sum all the possible paths of a quote-unquote photon, which in binary mechanics is a collection of quanta, of one-state quanta, all the possible paths that it can take in order to arrive at a destination from a particular source, okay?
As far as why an object couldn't travel in a straight line, I'm guessing you mean it's something apart from gravitational influences. I don't quite understand why something couldn't travel in a straight line.
When you say gravitational influences, gravity is not considered to be a force in binary mechanics. It does not appear in any of the equations of binary mechanics. I discussed all of the phenomena the gravity lovers omit in terms of the creation of matter in my slides presented yesterday, on up to the creation of protons, up to the creation of atoms, including the entire periodic table, and then up to molecules. That's aggregation, okay? I use the word aggregation because that word follows directly from the results obtained by applying the equations of binary mechanics, where matter is actually created as a consequence of applying these equations. Gravity is a word that, if you want to go back in history, so if gravity is something current in your thinking, well, I guess maybe you're in some kind of a time war. Maybe you're from the past.
Would you say that binary mechanics explains the apparent force of gravity that we can observe, though?
You see, with binary mechanics, I get the best of both worlds. In analysis of data, I can look at collections of quanta and treat them as waves and do wave analysis of them if I want. And that would involve real numbers. That would involve sort of a proxy assumption of continuous space and time. Even in the screen display of the binary mechanics simulator, you could look down on the right side column, and real numbers are used to tell you the position, which we might call in physics talk, the center of gravity of all of the quanta in proton bit cycles. And one can observe the movement of that position as protons move in the space. And so I can use the idea of continuous space-time and real numbers in my analysis of phenomena, but in terms of the theory of the origin of this phenomena, it's all binary, and only three binary math ideas are required, as I've stated, to
Okay.
understand it.
What exists in space when a cube is zero or empty? And what determines what exists when when it is one or filled?
So what happens when everything is zero in a spot cube? When the bit density or quanta density is zero, that is absolute vacuum in binary mechanics. However, I don't think you're going to have absolute vacuum anywhere for any length of time, because there's always incoming quanta, all of this radiation running around all over the
Yeah.
universe that we talk about. Those are quanta. You say, well, what is this radiation? What is EM radiation? Well, it couldn't be anything but quanta. In binary mechanics, it couldn't be anything else. So you have the answer of what it is. And those are always entering. And when they enter a volume with zero bit density or very low bit density, those quanta are going to be captured in the bit cycles of those spot cubes.
I mean, it would seem that there's always at least the very slight presence of electromagnetism or gravity or something. Is that factored in?
If there's any electromagnetic effects, by definition, it's not empty. Okay.
Yeah.
The magnetic field is in fact the distribution of L bits. It's that simple. Mm-hmm. And that is your magnetic field. Your electric field is the distribution of M-type quanta, or one states. If it's empty, I'm postulating essentially that this spatial lattice that we're talking about is actually a set of physical objects. That the spot unit, for example, is a physical object that inside it must contain certain mechanisms that we can only imagine. How do these equations get realized in physical reality? We don't know the answer to that. If these spot units are empty, as Jerry is asking about, the machinery still exists there, according to what binary mechanics is apparently saying. And I say apparently saying because with continuous space-time, you can almost say anything and get away with it. I mean, just look at all the theories of everything and all the conflicting theories out there. You can more or less say anything you want and get away with it. In binary mechanics, you can't do that. There's a certain scientific discipline. It must logically flow from what you already have. And in this case, if these spot units are empty, they contain no one states, and we're going to call that empty, then we have, which by the way are neutrinos. That's what neutrinos are, the zero states. Mm-hmm. But this machinery must continue to exist. If it didn't continue to exist, how could it capture incoming quanta and execute the laws of binary mechanics? You might say that the word for gravity in binary mechanics is aggregation.
Would binary mechanics suggest that it's pixelated, that it's sort of like a computer image? When you zoom in, you can tell that it's tiny squares. Is it similar to that or something altogether different?
Exactly. If you look at your computer screen right now, you can see people moving, and it looks like there must be continuous space and time, but really it's all pixels.
Wow.
That's exactly what binary mechanics is stating, or at least that's the hypothesis.
Would you say that the 3D cube grid or whatever it's called, would you say that it's stationary? Just
yes,
space?
Yes.
Okay.
In other words, one of the inescapable conclusions, in my opinion, is that this lattice of spot cubes is in fact an absolute reference frame.
Well, you had mentioned certain well-known and recently discovered phenomena that's been ignored. Like what specifically is that, and how would it apply in favor of binary mechanics?
One is the scattering data, which I mentioned, Jerry, where scattering results of protons hitting other protons reveal that at least the investigators claim that they reveal that the proton does not have a spherical shape. My work in binary mechanics right from the beginning showed that the proton does not have a spherical shape. And so that's what I would consider to be a well-known result, which is ignored. In terms of recently discovered phenomena, the so-called fractional charge, which is 1/3 of the elementary charge, which we see in quarks, and we also see in some recent experiments. There's a recent one from MIT again, claiming to have observed fractional charge in electron transfers. And it's a very complicated sort of material science work where they're making measurements which imply to them or signify to them that in fact you can observe that the electrons are moving between the layers of their material a fractional charge at a time, which is exactly the mechanism of motion which I presented in a previous Sunday session for you all. And the videos are up on my site and other places as well. I edited those down to some videos on my site so that you can review those mechanisms of motion, which other investigators are now confirming. There also was a recent finding that these investigators were aiming two lasers so that the two beams crossed each other and alleging that electrons were being created, as it were, from this interaction of two streams of what I would call quanta.